We're going to look at a relatively new feature available within Burp Suite, and that is the ability to take a results table of responses and identify interesting or anomalous responses where you're not exactly sure of the conditions that you're looking for. Maybe you're conducting some type of fuzzing attack where you're just sending a large number of payloads to the application and you want to be able to identify something of value, but you're not sure what. You just want to see, do you get some different results, some unique response from the application that might indicate some odd behavior and even a vulnerability. Now, this new mechanism is called Anomaly Rank, and it's implemented within Burp's Montoya API. The only way by default, or rather I should say that the standard tool that it's implemented as part of is Burp's Turbo Intruder extension developed by James Kettle. However, it may be a bit overkill for a lot of tasks, so there is also an extension developed where you can use it just in regular Intruder. And if you look in the BAP store, you'll find it here. It is the Rank Anomaly Context menu developed by Nick Koblentz. And just a bit of background on the algorithm itself. It's not machine learning based. It's not anomaly detection like a type of algorithm implemented with an ML library. Basically, the way it looks, or the way it works, is it looks at a number of metrics or measures from responses, and there's kind of a simple algorithm that looks at differences and tries to determine what interesting responses are based on the ones that have already been collected and certain thresholds that are hard-coded. If you're curious about how the algorithm actually works, I will have a reference to my newsletter where I break down how the algorithm works within the notes for this video, so check that out. If you're interested in the original implementation within Turbo Intruder, I will also link to James Kettle's video. But in this case, we're just going to look at a very simple intruder attack in one situation where you might want to use it. So I'm going to go over to the repeater tab here, and you'll see an interesting setup here. I have GET request. We're looking at Portswigger's Gin and Juice Shop, of course, which is a intentionally vulnerable web application. And you'll see something interesting in my path here. I'm specifying a custom hackverter tag where what I've done is a simple implementation of the Redamza mutation fuzzing generation tool. So how that works is it's going to generate, based on the value I provide, a number of mutations so that we can just probe the application and try to identify some interesting behavior. This may not be the most practical type of attack, but it's going to work, I think, quite well for our situation, or to at least demonstrate the anomaly rank capabilities. If you're curious about the implementation of that, I'll pull that up really quick from the hackverter menu, but I'll also post this code as well. So I have this implemented under Redamza here. This is just a custom tag within hackverter using Python. It doesn't take any arguments other than the input of whatever we're trying to fuzz against. It mutates that. It gives us the output. I'll post the code. It's not too interesting. So if I click send here, we can see how that behaves. You'll see that we get different responses, right? And if I go to logger, we can see what that custom tag has actually generated. And you'll see that it's generated some like nonsense payloads. But those are great in terms of testing how the server will behave to different inputs. And of course, we get different responses. But my question is now, what is the most interesting response or behavior that we'll see from the application that might indicate some weird behavioral quirk, some processing bug or issue? So what I'm going to do is send this to Intruder, and then navigate over to Intruder. And I'm just going to set up a very simple, I'm going to add a payload position that I'm not going to do anything with in this case. And I'm just going to go to null payloads. And I'm just going to say we're going to do 1,000 test cases. So a very simple setup. This isn't going to insert new payloads. It's just going to rely on our custom tag to generate payloads to put in place of the path using Redamza. And if I fire that off, one of the things that you'll actually notice when doing this in Intruder is that the tags are not evaluated here, but we can confirm that they are actually evaluated in the request going out because we can look at the history in Logger and see that, yes, the tag is actually being evaluated, but when it gets put in the results table, it's not there. So just as an aside, if you're doing this type of fuzzing with Redamza, you might want to know what seed actually was used to create that case. So another approach that you can take is to create a separate tag that takes as input a seed number, and then you can use Intruder to step through sequentially all of those different seeds, so you know how to recreate it with Redamza if you're interested. Nevertheless, in the results, we do have the actual payloads, and of course, our Intruder attack is done. So now we can actually look at the results. Now, the traditional way that you would do this, assuming you're looking for some type of interesting response, is you might look at the status codes, sorting those, and then looking through them to see if you find anything interesting. You might look for response lengths to see if there are any interesting response lengths. And sometimes this can be quite laborious, and it involves manually stepping through a lot of responses. And when you're also just working on a single measure like the response length or the status code, there are going to be certain situations where if that's all you're filtering for and you're not inspecting everything manually, you might miss some cases where the response length is the same or the status code is the same as something that you expect, but nevertheless, the response is actually different in some subtle way that is interesting. So what we can do here is we can use that extension that, again, is already installed, the Rank Anomaly context menu. Now, there's no UI here directly that we can apply that with. It is in the context menu. So I can right-click in here and go to Extensions and click Apply Anomaly Rank. And as you can see, what it does is it applies it just with that single item that I've selected. So what we actually want to do here is Control A in this table, select all of these request response pairs, go to Extensions, click Apply Anomaly Rank, and that will give us a rank of the most anomalous request responses, and then we can just filter that. And so it does give us this one that is quite interesting, which looks like a response was not received. So in this particular case, we sent a request that generated a payload, and the server did not respond. Maybe that's interesting. Unfortunately, as I mentioned, we don't have the actual payload. We don't know what payload that is. We can look in order in our logger. This is one of those situations where, as I mentioned, it would be helpful to have that seed number in Redamza so that we could easily recreate that. But other than that little issue, that's it. That's how Anomaly Rank works. It's a nice, simple way to do that comparison of a large number of responses to find something interesting directly within Intruder, or of course also available within Turbo Intruder. And if you're building extensions or tools within Burp, this is available as well through the Montoya API. So there's an easy way to implement these capabilities to find something interesting if you're developing some type of fuzzing algorithm or tool without having to reinvent how this works.